Hello everyone and welcome to the second live session, HMGT 400. I'm recording this meeting for other students who have not a chance to participate in this meeting. In today's meeting, I will review exercise 3, review a couple of examples for the individual assignment 2, and I will be happy to help you with your individual assignment 2 if you have any questions. So I would be also happy to read if you have decided to work with RStudio to look at your codes. You have a chance to share your screen and I can look at your code if this is any problem with that, and answering your question if you have any other questions. Okay, let me go ahead and share my screen. And if at any point you have any difficulties to hearing me, please also let me know. Okay. For the individual, for this week, it's coming weeks, and we will work on the exercise 3, and you are going to be prepared for the individual assignment 2. I know you just recently finished individual assignment 1, but in this class we have every 2 weeks a new assignment. So please be prepared to work on that as soon as possible, because you have finished your individual assignment 1. You are in really good shape to go ahead with that. I have a plan to read your assignments, and hopefully I will submit the grade by tomorrow night, so you have a chance to see my feedback and use that for the individual assignment 2. In my class, if you receive less than 80, so you have a chance to revise your assignments and resubmit without any penalty. Hopefully I don't expect anyone to be like that, but if there is anyone, so I will give you a chance to resubmit that. Okay, and first things first, let's go with the individual assignment 3. Individual assignment 3, ask a question similar to the other question in the individual assignment 1, in exercise 1 and 2, but the point is, for this exercise, we have 3 groups. And whenever we have 3 groups, the t-test is not longer a valid test. For that reason, for this week, you should focus on the ANOVA test. The ANOVA test, it's really similar. We can say this is kind of regression, but with only 2 variables. So even if you are working with any other package is that, for example, there is no ANOVA test, but you have a regression function. So you can do the regression, and the coefficient for the regression would be the same p-value for the ANOVA test. So for this exercise, you have 3 groups: low competitive market, moderate competitive market, and high competitive market. And the question is how the means change between these 3 groups. So for the first question, let's say compare the following information. Okay, so this is for the comparing, you should report the n mean standard deviation for all of 3. Everything is the same as individual assignment 1 and 2, individual exercise, exercise 1 and 2, but the difference is that you have 3 groups here. And this is what the main significant difference is. The main significant difference is that you should use ANOVA test. You know, some people, some experts, let's say, believe that because whenever we are using the categorical variable, and we have at least one categorical variable here, system membership, the ANOVA is not a valid test. That can be true, but for this class, I'm following the economics approach, and if you are using that approach, any binary variable still has a mean. For example, System membership is if being system is 1, not being a system is 0. So still there is a mean for this variable, and then you can use the ANOVA test. So that's the reason, and that's this is for this class. But if you have decided to publish a paper, so make sure to use the chi-square for that and look at the journal. And so most of the epidemiology journal like to see the chi-square for the binary, for the categorical variable. But for this class, I'm just noticing that if someone asks a question about you, okay, so what do you think? This is a categorical variable and you are not permitted to use ANOVA, so that's for this example. We are focusing on ANOVA here. And how many of participants in this Zoom are using RStudio? Jerry, I know you are using RStudio. Kenya, are you using RStudio? Do you use RStudio or Excel?
No, I use Excel.
Excel. Ashley, what about you?
I'm using RStudio.
Two.
Avia, and you are using RStudio, I believe so, right?
Mm-hmm.
Shirley?
Yes, I'm using RStudio.
Okay, great. So I will review RStudio and then back to the Excel for other class members who are using Excel. If you are using RStudio, you should use the Victory E3 codes, and the E3 codes is located in the class instruction. And because if you are using RStudio, because this is the third exercise, so you don't need to install the dplyr package, you just need to load the dplyr package. And the code by default, the sync command is muted. I'm not sure, I believe the code is, even in the class, the sync command is muted. If you like to save everything, so make sure to unmute this one. And to unmute this one, the sync command, you should just remove the pound sign. As long as you have this, and for this specific exercise, please run everything one time. I will explain why. And if you decided to go step by step, make sure that, and make sure you run the earlier command, earlier lines before, because for this line, in line 26, the code converts the Herfindahl index to the categorical variable. You use a clustering them and clustering the data set to do that. Or if you want to go with a step-by-step, running the code step by step and did not run this, more likely when you get to the very end of the code, you will receive the error term. So highlight everything and run the codes. And I believe you will have everything here. Yes, you can, as long as you see this plot, you have everything. And you can use the backward key to see all the plots. There is 6 different type of plots on this. This is density plot. So I add a few functions for this plot. If you decided to work in the future and you like to have a color for the graph. So this code can help you to just add a different color to your graph. So this is the code with some kind of graphical interface. Okay, as long as you can see this, you are in the right place. And let's go back and then mute this command and run everything. I want to show you something here in this. You can just look at a few examples and make sure you're on the right track. Okay, whenever you run this, the first thing is this part, right? This is the 3 difference 0, 1, 2, and please make sure to look at this. The 0 is high competitive, 1 is for moderate, and 2 is low. This is also true for the Excel user. The 0 is high competitive market here. 1 is moderate, and 2 is low. And you see here, they say with 2 more variables here, so you should give more space to this. should give more space to this, and I'm gonna run this again. I'm gonna run from the very beginning. Okay, this is here 0, 1, and still need more, so you need to give even more space to this to have everything here. So these are the numbers for mean and standard deviation, right? This is the means. If you want to compare your number with this is the means. This is the 4 or 0 was high, 1 was moderate, and 2 is stays as a low competitive market. So whenever you see the NaN, non-applicable, the data is not, I mean, there's no data for this part, so then you can report empty, or just you can report the hi-fi key, or just you can report the Na as a non-applicable. So make sure there is not, this is not an error. So this is because there is no data here. And then we should subset the data, and if you decided to work in the individual assignment tool and like to learn more about RStudio, and if you are comparing two states, or you decided to work with a clinic and hospital for imaging data sets, so then you need to subset the data. This part of the code subset the data to 3 different. So for example, I'm creating one data set for the high competitive markets, other data set for the moderate, and the other one for the low competitive markets. And you see this command is a subset command, and this is the name of the data set, and then this is the variable I'm using for the filtering. So I need to create this first to get this result for the t-test. So this is actually the number of observation. So let's say number of observation is here for all of them. And then after this is the ANOVA test. And this is the point. You should convert this data to a factor data set, a factor variable, to get the ANOVA test here. I mean, you don't need to do that, so just need to run the code. And this is an example for the ANOVA test. And for the ANOVA, I will explain in the Excel the real formula, so then you can see the formula that's using for the ANOVA test. But for the ANOVA test, you can see the F value. We have a T value for 2 population, and we have a F value for more than 2 population. So whenever we have 3 or 5, 3 above, 3, 4, 5, anything else, so the F value is a valid one. And but you should report the P value, right? And the P value means the same thing as a t-test, because the P value, if the P value is less than 0.05, then there's a significant differences between these 3 groups, or at least one of the group is not equal to others. The meaning of the p-value in Excel in the ANOVA test does not mean all of 3 means are different. They say at least one means is different with 2 others. That's the meaning of this, and you should report the p-value here on this line. So for the question 1 and 2, so you're gonna report this and the p-value, and based on the significant differences, you can say, okay, at least one of the means is different, and then look at the means and see which of them is the higher, and to answer the questions. For example, use the density curve and compare hospital cost and revenue between 3 markets. So you should report this, right? This is the first density curve. This is the place I ask a density for this. And if you are using Excel, you are not able to do this. And then instead you can use maybe bar chart or box plot to show this distribution. I prefer box plot because the bar graph doesn't show the distribution. And if you look at the density plots, And the red line is for revenue, the blue line is for the cost, and see they are following each other. Sometimes the cost is higher specifically for this. Let's look at this. If you look at this, so the bigger size, you see sometimes the cost is over revenue. It does mean those are the hospitals with negative benefit. Okay, what is the impact of being in a high competitive market on hospital revenue and cost? So for this question, do you think is being a high competitive market has positive impact as a benefit? What about the number of Medicare? Do you think the hospital? Okay, you know, there is two ways to answer these questions. I mean, this question, actually, this one question must have 4 different parts. To answer this, in RStudio, I wrote a regression model here. A regression model here to show how it's different. So because you have more than 2 elements, whenever you have more than 1 element to compare, so because the ANOVA compared 2 groups for only 1 variable, right? T-test compared 2 groups only for 1 variable. Whenever you have more than 1 variable, so the formula for this, if you have any question, ask me at any point. For example, for this, I'm gonna say high competitive market is equal to the benefit, right? The benefit is y equal to beta naught plus beta 1x. And this is the ANOVA, right? This is the ANOVA. It's a very simple regression. But I like to see what is the impact and why xy, here's the benefit, right? And if I have other variables, the Medicare, I have the Medicaid, okay, that's it, right? Medicare and Medicare, other variables. So even the other variables, so I mean, any other variables here in this, plus it's plus something else. So I mean, all other variables, then you are not able to use the ANOVA. It is possible. It is possible to compare them, each of them, but still that doesn't give you the real response. Because if you look at the real community, you say you are in the hospital, and as a CEO, you want to see what's the impact of all of this variable on your benefits. You cannot compare each of them separately. You have to run a regression and put all of them together to see the real numbers. So for this, in RStudio, there is a comment here for regression. And let's see, let's find a comment here. I believe there is some comment some point to show this regression. Where is the GLM? Let me search for this. Okay, cost density. If there is no comment, I have to write here the comment and then you can use that. So the comment for the regression should be this. Let me copy from the other week. I believe it was a comment here. Or maybe I update in the new version. Should be a comment here. Okay, there's nothing here. Let me look at the comment from the other class profile. Exercise 4. Okay, this is the comment. E3. And I will post it in the class. So if you're already working with that and the part of, please make sure to download the new codes. The question 4, let me call it Q4. And the question is, what is the impact of benefit of being in each of these markets on hospital benefits, right? And for this, you have this variable. Sorry, I'm working with other computer. And let me do it here. Where is the place I created the factor variable? Okay, here. Benefit with this variable. And okay, what's the impact? Okay, high competitive markets, Medicare, Medicaid, and all other variables. So let's stay with ownership. Do you have ownership? We don't have ownership here. We have Medicare and Medicaid here. Medicare discharge. Medicaid discharge. Plus system member, right? One of them was system member. Let's stay with this. And if you run this code, we should have this probably, yeah, here we go. This is the regression model, and I know this is not the, you still did not read the regression, correct? The regression is for week 5. Okay, let me go and modify this section because you are not able to run a regression. You should read the regression first. For this question, look at the benefit. You don't need to run a regression because you still need to go to the week 5 to read the regression. Look at the benefit first, this variable, but look at the means. And let's see if the mean is significant. If the means is significant, then we should run 4 different t-tests, run everything together. That's the way I follow this. Where is the benefit here? Within the cat, hospital bed, payer, work, factor. Oh, here you go. The benefit is significant, right? There is a significant difference here. So then it does mean at least one of the mean is different. So let's look at this. Means this is the benefit, right? So here I have 190, so I'm just rounded them 190. I have 394 and I have 4. Yeah, this is the smallest number, right? Let's compare here. 0 was, anyone wrote 0 was for high or for low? Any of you make a note? Did any of you make a note? No. Okay, let me look at this. 0 was for
High.
okay.
0 was for high.
0 was for high.
Yes.
0 high, 1 for moderate, and 2 was for low. Okay, thank you. 0 for high, and you have this one, right? You have 0 here. You have moderate, and you have this. Okay, and if you rounded them by 6, you're gonna have this, right? 0.2, 3.9, 1, 2, 3, 4, 5, 6. This, and we have this one. Okay. Now you can say which of them is more likely. So I expect that this is really high, right? So at least maybe these two are not very different from each other, but this is it. To make sure which of them is the correct one, you should run a different t-test between each variable. Here is it. you can run a t-test between high competitive market and moderate competitive market and high competitive market and low competitive market to see which of them is significant. And then based on the result of t-test, this is the t-test for, I should run this first. This is the t-test for medical. That's the reason I say you should run the code from the very beginning, otherwise you're gonna have a problem. Oh, here. This is the result of t-test comparing Medicare discharge with competitive, high competitive and moderate, and high competitive and low competitive markets. So as both of them is significant here, so you can do the same thing for benefit. Instead of discharge, make sure to add a benefit here. So the code should be something like this. Okay, code should be something like this. Benefit. And there's a significant difference here, and this is between high and moderate. And you can run the same thing between high and low. And there is significant difference, and there is one other between low competitive and moderate competitive, right? And it is not significant, right? And if you look at the means, 41 in comparison to 39, I don't see any significant difference, but 190 compared to 39 is different. 190 compared to 41 is different, but these two are not significant different. That's the way you should answer this question. Okay. And for your final findings, you should just discuss anything that are significant and then look at the means and then have your suggestion, not more than one paragraph. And make sure to include all of the plots. Any question for RStudio users? Okay, let me go back. Yes.
No, no question.
Okay, great, thank you. Okay, and this is for RStudio, and as long as you have this code, if you as long as you have the codes in RStudio, and you can see everything here. So if you run the code, and you will have a file like this in drive C, UMUC, and this is here, right? I just run it in 5:09 p.m. today, and you will see something like this. Everything is here. And I will not modify the code for the regression because you don't need to do that regression. Just go ahead with the different t-test. Okay, let's go back to exercise 3, and this time I'm gonna look at the Excel to compute this. For the Excel users, anything like any other part, n mean standard deviation is very similar to the exercise 1 and 2. The only difference is the way you want to compute the ANOVA test. And as I explained before, the data set is a long data. Anyone want to explain what's the differences between long data and wide data? Do you know the differences between long and wide?
Yes.
Okay, please.
So the wide data is when it goes across the top,
Mm-hmm.
and long is when it's just going up and down.
Okay, thank you. Yes, and the wide data is whenever, for example, if you're comparing the income between 3 hospitals. So for each hospital, with three markets, for each market you have one variable. Number of income for market high, number of income, the income for the low market and the income for the moderate market. But the data is a long data. Because the data is long data, the ANOVA function in Excel is not useful. But I'm explaining this, even this is the information is really helpful for RStudio users. This is the formula to compute the ANOVA manually. For computing the manually, you should run this, right? The F equal to MSB divided by MSW. And what is the MSB and MSW? If you should go back, I'm starting from here. For ANOVA test, we have a sum square for the total, sum square of between group, and sum square of within group. The ANOVA just compare the differences. I compare the ratio. The F is the ratio between SSB and SSV, between group and within group. So this is the ANOVA test. For the between group is this formula, right? Is a square root of all of the variable. It's a sigma of a square root of all of the variable divided by number of observation for that specific variable. And the minus t but on power 2 divided by n is not really important. Look at this part. It could be sum of all of the differences between the mean of each variable and the mean of the population. And for the between group should be the mean of every individual minus the mean of the that group on power of 2. And whenever you have these two, you can just combine and add together and get the SS total. So I'm going to walk through this formula using Excel. And for this example, I will explain the hospital bed. And then after that, you can compute for any other variable. The first thing is I'm going to compute on this one, right? Because if I compute only any of these two, I can get the third one, right? I can compute SST, I can compute SSB and compute SSW. Or I can compute SSW, SSB, and then get SST or any other. I don't need to compute all of them together. I'm going to compute only two of them and then we'll get the results for this one. For now, I'm going to compute the SSB between group. And for SSB between group, I need to have the mean for variable for every group. So I have high, moderate, and low, and say, I should compute the mean for high, and to get a mean for high, so I should use the hospital bed and Herfindahl index CAT, right? I have this Herfindahl index CAT, so I hided anything else. So just keep these two variables here. And these two variables are like this. This is the real data. I just hided everything else here. Let me go back to this. And what happened to my formula? Okay, here you go. I have this. I have the means for this variable. The mean for hospital bed for high competitive market 130, hospital bed for moderate 420, and hospital bed for low is 337. And this is the average ifs comment, right? I'm using this comment and say, okay, compute the average for G and filter by 0. And then I get high, the same filter by 1 to get moderate, filter by 2 to get low. Then I need the square root of all of this variable. Look at this, right? I need this. The square root, I'm going to compute the square root for this variable. For total hospital bed, as all of them, the square root for only a high, I'm computing this, right? So I have to do this. This is for total. For each variable, I'm going to say, okay, this for each variable, I have observation for each hospital, the mean, the beds for each hospital, xi, right? Xi minus xg. J is a stand for the group. I have this, and I'm computing this class. I say this one, oh, this is for within group. I'm computing within group. The formula is xij minus xj, right? Xj is this one, mean for the group. Xi is this one. Xi, this is the xi, xij minus x for one observation, right? For one hospital, this is and 9, for example, this value 376 minus 19 on power of 2. And if you do it manually, this one minus this, you can get this. And if you do it on power of 2, you can get this. This is exactly this number, right? So I want to show you how to do it. So this is this number minus this, you can get this, 357. And if you power on, get the power of 2, you can get these numbers. And because the this is the absolute value, though there's no importance of each of them is the first, you can minus this number from this, and this the formula is xij, this number minus mean. But even if you subtract this one from this, it will not change the result. I do it for the total beds. I do this for the high. I do this for the moderate and to the low. So whenever you do it for one of them, you can just drag it to the very end, get for the all other variables. Make sure to do this. And then I need the sum of this. This is SSW, right? So whenever you have all of them for every hospital, you should get the summary of all of them. I have a sum of all of them, right? The sum of this one, line 2 till line 3031. I have all of them together. So whenever you have this, I can compute this one. SSW is sum of all of this, high, moderate, and low, right? And I have total. For the total, I have this one, right? I have the sum of this only. So if I subtract them together, I can get sum of between. The sum of between is really long formula. You don't need to go for each of them separately. So you can compute the SS between group and total and get the SSB. Whenever you have these two variables, so the next option is this, to get these two, MSB and MSW. And you see MSB is SSB, this variable, divided by K minus 1. The K is number of group. I have the number of group, right? I have 3 groups, 3 minus 2, I get 2. And I have total observations 3031, and I have N minus K, 3031 minus 3, I can get 30. I mean the 30, this is 3031 minus 3, right? 3028, but probably there's one missing here. So that's it. You don't see 3027. Okay. That's because one missing for at least one of this observation has no data for the beds. So whenever you have these two, you can get this MSB. MSB is this one, this number divided by this number. And MSW is this number divided by this number. So you can get this too. And whenever you have these two together, so you can use this to compute B30, this MSB divided by MSW, right? This is this one. And you have the F value. Whenever you have F value, you can compute the P value by T district RT, and it should be this B035, this one, B047, this one nominator, and B03048 denominator. So you should consider all of the N and K, because for t-test, we have only the degree of freedom. For here, for the ANOVA test, we have a degree of freedom and number of groups. So that's the formula. You can compute the F value based on this, and the F value based on this is a 0.00, or there is a significant differences between all of at least one of these groups. More likely between group 1 and the other groups, because 377 with 420 is not big differences. I know the difference is 50, but probably there's a wide standard deviation variation even here. So I review one more time. I know it's kind of confusing, but make sure to just review this video, watch this video several times. I'm computing SSW, and to compute the SSW for every single variable. So I'm computing only for hospital bed, and this is the p-value for only hospital bed. If you want to compute for any other value, you should follow all of this process. You should get the total for total observation for all of this variable and total. So first thing first, compute the means for each variable, for each group. So this is the mean for entire group, all of the hospital bed. This is the mean for high, moderate, and low. Whenever you have this variable, you can compute this one. This sigma, right? This. You are computing this because this is a sigma of sigma, right? You have this. You should subtract this one from means and on power of 2. And then do it for all of the variable. Do the same for the high, moderate, and low. And then when you have all of this, compute the sum of all of this square root differences between the observation for each hospital and the means for that specific group. Whenever you have this, you can compute the SST. The SST, what is that? Okay. SST is this one. SSW is all of this, 1, 2, 3, right? This is T, this is W, and when you have T and W, basically you look at this formula, you have a T and W, and then you can compute B, right? B is equal to SST minus SSW. And you can get SSB, and then you should compute the degree of freedom for the group, K minus 1, 3 groups, minus 1, 2, degree of freedom for total sample, 3031 minus number of K, you can get this, and there is one variable here and one missing for the bed, and that's the reason you cannot see 3028, you can see 3027. Whenever you have this, you should compute MSB, and the MSB is this number divided by this, MSW, this number divided by 3048, right? Divided by this, degree of freedom, and then compute F by dividing this together, MSB divided by MSW. And then when you have this value, F value, you can compute the P value for this observation, and the P value should be 3053, this F, right? This is the F value. B3047, numerator for the group, number of groups, minus 1, divide, and total observation minus K is 3031 minus 3 for that specific group, and we can get 3027. I can know 3031 minus 3 gives you 3028, but because there's one missing here for bed, so we have 3027. This is the real long way to compute the ANOVA, and I can say this is one of the longest exercise using Excel, but please watch this video and you can use this for the other part of the exercise 3 for Excel users. And I'm going to post this, and I believe there is another video I explained that the class that you can use that. That's the same thing as I explained here. This is for exercise 3. Any questions so far? No questions. Okay. If there's no questions, I would like to give you a chance to present if you like, or ask your question for your individual assignment too. Otherwise, I can go with one example. Any question? Anyone is ready to talk about his or her individual assignment too? I know it's very early. It's still 3 days after individual assignment 1. Or you like me to go through an example? No question. Jerry, you want
Please
to
go
talk?
through an example.
Yeah, if you could go through an example, that would be good.
Okay. And so please let me your topics. Mario, what's your topic, Mario? Please, all of you, please, Jerry, what's your topic? Mario, do you want to look at your topic? I like to have all of your topics, so I can give you example based on the topic you have. So this is the chance for the people who are for the student who participate in this meeting. Mario, what's your topic? Do you know? Do you want to look at your topic? Mario, individual assignment 2. Jerry, do you know your topic?
No, I'm looking it up really quick.
Shirley, do you know your topic? Okay, please look at your topic and I can look at you, but you look and let me know.
I was comparing discharges for ambulatory care sensitive conditions per 1,000 Medicare enrollees between.
Okay. Between black and white?
No, between 2 states.
Do you know which states? Or you still didn't choose a state?
Yeah, no, I just,
Okay.
I didn't pull it off a data sheet. I was just 2
Okay.
random states that I picked.
Okay. So I can give you an example. I will go through an example here and then you can use the same state if you like.
Okay.
Ambulatory visits between black and white. I believe I have ambulatory visit between 2 states. Let's see if I have anything here. Minnesota, California. Okay, person beneficiary. Let me go with this example and then go with this. Okay, this is an example between any of our. Mari, did you look at your topic? Class, would you please share your topic for the assignment too? As long as I'm working on this, in any point you can just jump up and just say something about your topic.
Mine is comparison between the percent of Medicare beneficiaries, Part A, eligible between blacks and whites.
Okay, thank you, Mari.
And mine is comparing average annual percentage of diabetic Medicare enrollees age 65 to 75 having hemoglobin A1C in Maryland and Virginia.
Okay, great. And okay, Keisha.
Mine is comparing the average percent of female Medicare enrollees age 67 to 69 having at least 1 mammogram
Okay.
over a 2-year period between black and white population.
Okay. And Kenya.
Yes, give me one moment. Mine is comparing average length of stay between acute care and not acute care hospitals.
Okay. Okay. For Minnesota data. Okay. Thank you. Okay, let me go with Jerry's example. And Jerry, this example is for this example I compare the hemoglobin between New Jersey and Florida. So you can use this. You can use this to a state. So I'm gonna modify this code. So based on your topic, and your topic was ambulatory visit, correct?
Ambulatory, yeah, care sensitive conditions.
You know, whenever you are using 2 states, because for each variable in the Medicare national data by county, so I believe all of you except Kenya, you should use the Medicare national data by county. So for all of the variables, so you should just all of the subjects. If you're, for every single variable in this data set, you have 3 different variables. So for example, the ambulatory visit, I have ambulatory visit for black, ambulatory visit for white here, right? Black, white, and overall. Whenever you are comparing 2 states, you should use this variable, ambulatory visit overall. And then you can modify this code and to get this done here. I'm modifying I replace all of the hemoglobin with this. And for any other class member who is watching this video, if you are using 2 states, I know a couple of you are using this. If you decided your state, this is fine. Otherwise, you can stay with the New Jersey and Florida and just change the variable name here. And this is ambulatory visit. And I will share this code with you, Jerry. So just please make sure to send me an email after this meeting. So I believe I just did that. And for this, first thing first, you should compute in subset data. That was a place I say using the subset data and exercise 2 is really helpful command for any other variables. So I have 2 data sets, New Jersey and Florida. And I have the means here, right? Ambulatory visits. I have the standard deviation. And I have the number of observation. You can compare with your number later, Jerry. And then the t-test. You can run all of them together. Just I'm running to go step by step. And this is a p-value, right? This is the significant differences. This is the box plots. And this is the density plots. And okay, it's more likely Florida has a higher, right? What the mean says. The Florida 79, yeah, that's correct. Florida is higher, and this is a significant differences. Let me save this code. And it was ambulatory visits. Okay. Okay, no, that was a problem with this. Ambulatory visits. Any question, Jerry?
No, sir.
Okay. Okay, I will share with you. Just make sure to send me an email.
Okay.
Mari is comparing Medicare beneficiary between black and white, right? Percent of Medicare beneficiary.
Yep.
Let me close this. Percent of Medicare beneficiary. Percent of Medicare beneficiary. Where is this? Medicare enrollee. Yeah. This is California and Maryland. Here. And Mari, please send me an email. I will share the codes with you. This is very interesting because, the data set didn't provide the percent of beneficiary. The data set provided number of beneficiaries. So the point about this assignment, and I know a few other students have submitted a topic like this, you should look at, you should compute the percentage. And these lines of code, I compute the percentage. The computed percentage should total number of black divided by total number of overall of publication, right? So I can compute.
Doctor, I can't use RStudio. Remember, I can't get RStudio to run any of my codes.
I remember that. So I will review this. You look at this. I will submit a text file to you, or I will give you an example on Excel, and you can work on the Excel. Do you want to work with Excel?
Okay. Yes, because I tried so hard to get RStudio to work for me, but my Chromebook.
I remember that.
Okay.
Let me finish this for the other class member.
Okay.
I will back to Excel for you. specific. But even
Yes,
if
sir.
you're working with Excel, you should compute these two variables. Number of beneficiary black divided by number of beneficiary overall. Multiply 100 to get the percentage of these two. And then when you have these two together, you can easily compute the mean, standard deviation, and this is for all the class members who are using in this example. And here. Okay, I will go to the Excel later, Mari, if this is fine with you, after I finish the RStudio part. Is it
Yes,
okay
sir.
with you? Okay, thank you. Sherry, do you use RStudio or Excel? Oh, no, okay. Shirley using Excel.
RStudio,
Oh, RStudio.
yes.
A1C between Maryland and Virginia, correct?
Yes,
That was your topic.
yes.
A1C between Maryland, and I believe I have an A1C. If I don't have, I can compute. Do I have A1C here? I have A1C Virginia, Maryland here. Similar to Jerry, Sherry, you should compute two data sets, right? And you should also, this is the variable you need, hemoglobin overall, it's A1C.
Okay,
You have this data set, drive CUMUC, and you should compute two subset data. And the subset data compute the Virginia first and Maryland first, and then we can go through the mean and the standard deviation, 87, 85, 3.5, 2.0, and look at the number of observation and t-test to compute. The t-test is highly significant. Look at the box graph. So you can see how you can just drag it and drag on the right, left to get. And if you look at the density plot, probably Maryland has a higher, right? If you look at the means, probably Maryland is higher. So yeah, that's correct. Maryland is, oh, okay, that's, no, Virginia is here. The red line is over the blue line. So the Virginia is higher, and this is accurate 87 in comparison to 85. And Shirley, please send me an email. I will share the codes with you.
okay.
Thank you. Keisha, and your topic was mammogram between black and white, correct? And okay, open
Yes, I'm sorry.
mammogram. Okay, sure. This is happening all the time to me on the Zoom. Okay. And okay, this, I say the mammogram, and this is the lipid. Let me change this code. You have the same data sets, and the variable you should use is the percent of mammogram between black and white. So this is the variable you should use, percent of mammogram black and percent of mammogram white. Because I have all other I have this code for lipid, I can just change the lipid. Oh, let me go with this. It's much easier to go with the entire variable names. Percent of mammogram, I'm gonna change all of them to mammogram. And should be here, percent of mammogram. And okay, percent of mammogram. Black, the same for white. The percent of mammogram white. And okay, this is white. And this is white, and this is ready to run. And you see that it's very similar. It's very easy to write, to modify the codes for RStudio. So this is 60, 61. Probably it's not significant, but let's see the test. Yeah, interesting. Significant. I don't expect it to see the significantly here. Person mammogram, what is this? I have 60, 61. Okay. Anyhow, I trusted the t-test. And this is the density plots, right? And this is the density plots. And you can do it to the top left, right? You can say top left. And you can get this. Okay. And this is this box plots. Okay, please also make sure to send me an email. I will share the codes with you. So I have Kenya and Mari to go to the Excel. For the Excel user, the data set is Medicare national data by county, right? Sure. Okay, class, any question for me? Okay, if you don't have any question, thank you very much for being in the Zoom. I will post this to the class.
Thank you so
Thanks
much.
for all your
You're
help.
welcome. You take care. Have a good
All
day.
right.
Goodbye.
Bye-bye.
Take care.
Thank you, sir.
You're welcome. Goodbye.
Thank
Bye.
you.
Sure, absolutely.
Thank you.
You're welcome. Goodbye. And this is the end of Zoom session, class. Thank you and goodbye.